Greetings everybody, and welcome to our next example in cross products. So what we're asked to do in this case is to find a vector that's going to be orthogonal to the plane which contains the points P, Q, and R. Now the idea behind doing this is basically we're going to use a property of the cross products. That we've got our point here P, we've got a point Q, and then we've got a point R. Well, if we look at the vectors between those points, what we are able to do then is to take the cross product of those vectors. And so what we'll have is a vector that's going to be orthogonal to both those two vectors between P and Q and P and R. And that's really what the cross product is. That we're really using this fact that the cross product is orthogonal to each of its component vectors. And so the idea is we just compute our vectors between those points, take the cross product, and we have the vector that we need. So let's see how that might work. So for our vector between P and Q, again, we're just doing ending minus beginning. So we have minus 1, minus 1. Then we have 1 minus a minus 1. And then we have a minus 1, minus 1. And so what we have for our vector from P to Q is just a minus 2, a 2, and a negative 2. Now, likewise, if we want to do the vector between P and R, what we have there is, again, ending minus beginning. So we have 1 minus 1. We have 1 minus a negative 1. And then finally, another 1 minus 1. So for this vector, we have 0, 2, and 0. So now the vector that's going to be orthogonal to the plane containing P and Q, or at least one of the vectors that's going to be orthogonal to the plane containing P, Q, and R, will be now our vector PR cross PQ. And so what we have for that one, again, drawing our mnemonic to help us remember which cross products that we take. So we have PR being given by 0, 2, 0. PQ being given by negative 2, 2, and negative 2. And so what are our determinants? Well, for the first one, get rid of the first row, get rid of the first column, and we have the determinant 2, 0, 2, negative 2. For our second determinant, we have the negative of, get rid of the first row, get rid of the second column, 0, 0, negative 2, negative 2. And then finally, for the third determinant, we get rid of the first row, get rid of the third column, and we have 0, 2, negative 2, 2. So what this actually gives to us for the vector itself, we have a negative 4 minus 0 for the first determinant, a negative 0 minus 0, and then finally for the third, we have 0 minus a negative 4. And so what do we have ultimately as our cross product? A negative 4, a 0, and a 4. And so one of these vectors, so this is going to be one vector that's going to be orthogonal, or another vector is just going to be the negative of that one, so we just change that direction. And so another possible vector would be 4, 0, and negative 4, or any other vector that's going to be a scalar multiple of those two. And so what we have for Our answer is just our first option, 4, 0, -4. I hope you've enjoyed this problem, and I will see you guys in the next one. Take care.